Thank you, Marinus. I'm having a bad day. Thank you. For both of you, Ed too, you're keeping an eye on me. I'm appreciative of that, I'll tell you. Because otherwise we'd have no recordings at all. So this is the full picture of the I/O server in place with the before triggers and the after triggers in place where applicable on whatever tables are applicable. Now, I just had a question here from Ed. Right. He said, if there are 10 programs using a file, and I create an I/O server and change one of the programs to use the I/O server, can I place that into production without having to change the other 9 programs to use the I/O server at that time? Or can I change them over time? The answer is absolutely. You can create an I/O server. You can actually put it into production when no programs are using it, because it's a program, or sorry, it is a procedure in a module bound into a service program. So as long as it's been tested and does what it's supposed to do, you can put it into production, and only later on you can change programs one at a time to use that particular I/O server. So there's no need to make all of them use the one I/O server. As you change program, of course, an incentive to make that move, if you're including sort of specialized code in your I/O server, which we'll talk about just now, then it might be of benefit to move your programs across as quickly as possible. But when you see the code and you see how it goes together, then you will understand how that all works. Right, so that was the one question. The other question was from Dean. Don't you still have to control who can call the I/O server program? We don't want developers updating production data. Now, I read this one a couple of times, Dean, and I read it with the second one, which you said you've got text and production on the same partition, which means I'm assuming that you have your development environment on another partition. So I'm going to say this, if you can appreciate the sort of situation. When I have set up, and let me rather show it to you, if I can find out what I'm looking for. Let me rather show it to you. Oh dear, I'm trying to find my... Okay, I've got a mail through from a Dean on a trigger question, which I will have a look at just now. Oh dear. It seems as though I'm going to have to just pause the sharing for a moment, because I need to... I don't understand how this is working. Why is this not working? Computer, I don't mind meeting. I'm just going to stop the screen sharing for a moment. I don't know why it's misbehaving. Okay, now let me get myself sorted out. Right, I'm going to start the screen share again. And I'm going to start the PowerPoint presentation again. Right. Now I have here, okay. I have, at this particular moment, I've opened up an AO session, and this is the test environment. And I just want to show you what I do with my library list. And this is the way I manipulate how and what files the IO server accesses. Now you'll notice that I've got a test library and a production library, and here is my test database library. There it is there. And my production database library there. Now, having the library list set up in that order, my IO server is in the production environment because, hang on, I've just got to find my chat box again, which seems to have gone missing. Oh, there it is. Okay. So, right. So if you have separate data libraries, okay, test, development, and production all on one partition in our environment, which is exactly the same as mine. And so what I do is I set up my library list to look like this, so that the test environment or the developing environment comes first, the test comes second, and the production comes third. Now in the physical database, which is where the IO servers are located, by the way, because IO servers I see as part of the database, and therefore they are compiled within the database, the physical database schema, not in a program schema. And so what happens is, even if the service program is in your production environment, there, as long as you have the library list in this way, the IO server will locate and open files in the test database. Now, if you take the authority of the physical production database, and if you take the developer's authority away from the physical production database, then even though the IO server is in the production database, they will not be able to access physical tables in the production database. So it's better, if you want to protect your database from your test and production environments from your developers, rather remove their authority to the physical database and let them have access to the IO servers. That is why earlier on I asked, do you have a public exclude option on your database files? If you have that, then on your production and your test environments, the server program will only be able to pick up the database that it's actually allowed to pick up. Does that answer the question, Dean? It's important that this is actually comfortable, because I want to see that the recorder is recording. Yes, it is. So you're happy that that answers the question that you were actually asking? Okay. Yeah. It's all a matter of authorities, really. If you have your IO server usable by everybody, it doesn't matter, because the IO server can only open files that are available to that user. You just have to play with it until you get it to work. But from my case, the way I've set up my library list, I always get, even though the IO server is in production, it always picks up the test files if I'm in test, or the dev files if I'm in dev. Okay, good. Now, I'm looking for the other question. Okay, same petition. Okay, there was just a question from Ed. Service programs are faster than external program calls. That is correct. Reason for that is that the addresses and the binding and everything else is sorted out at compile time. So at execution time, the call is relatively quick. Whereas when you call an external program, then you have to initialize that whole program, and that takes slightly more overhead than normal. What is this? Here we are. Okay. Now let's have a look at the question that Dean asked about triggers, which was some time ago. Have you heard of using a trigger mediator program to implement triggers? The idea is the same program is added as a trigger to all files that need a trigger. Then in a database file, you maintain what program should actually be called when the trigger fires. The trigger mediator accepts the trigger buffers and then checks the file to know what program to pass the trigger buffers to. The database file contains attributes to indicate when the program should be called, before, after, plus, insert, etc. The database file also allows you to disable the trigger as well. This approach makes it easier to make changes to the trigger programs because you don't need to wait for the file to be free before updating the program. Okay. I will answer this one because, yes, that is one method that I have seen being used. I don't use it for two reasons. First of all, it's simply doing what the database already does. And that's depending on how you attach your triggers. The database calls the ones that are there and the ones that are not. So it's all done by the database. It also creates a significant overhead because you now have something in the middle that is now calling, and so you're getting a choke point there. And the third problem, well, the third thing is that this is exactly what AO is designed to do. You can manipulate triggers using AO. Let me just get in the trigger workbench. Yeah, we've got use this advanced modernization workshop schemas. We can go in here and we can look up the workbench. And then I have the ability to switch that to a trigger view. And I can actually see all the triggers designed for the whole database. I can then open up and show the, I can also do the tables view and open up and show triggers. And it shows me all the triggers attached to which files. And when I change a trigger, I can enable or disable or manage it. So AO provides you with all the functions of a trigger mediator without overlaying an extra layer of functionality on top. And so it manages the triggers. If you have a mediator trigger, you've got to have some fairly significant management tools to make sure you've got the right triggers attached to the right thing. And so I've never used that type of thing, although I do know that there are people who do. Okay, so that answers that question. If you want any follow-up questions on that one, I'm more than happy to discuss it. If it really, sorry, Dean, was that Dean or Ed? That was Dean. If you really want to go into it in a bit more depth, Dean, then please let me know, and we can maybe set up a short WebEx just to discuss specifics one-on-one with you. Okay, just as a way of focusing in on one specific area. Okay. I think we're all caught up. Now, of course, I come to my second most fun thing in my life when I'm writing applications, is to actually start working and showing you some of the code that I use to create IO servers, some of the standards, the methods. So I'm going to find my RDI if I can. And I have already got open in RDI, I've got the source for the database for the Advanced Modernization Workshop, which is the tool that we're using, or the mini database that we are building on. Now, an IO server, my naming standard for IO server modules is file name followed by $. You can see it there. The file name is cust.mstf, and its IO server is cust.mstf $. There's the file on that side and the $ service program on this side. Now, I want to take you through this slowly. I want to be a complete pain and emphasize carefully what you need to think about with IO servers, because very powerful they are, but you can scramble them to such an extent that they become very difficult for application developers to actually use. And the minute you start going in that direction, you will find people stop using them. And then, of course, the whole philosophy of IO servers and being a border control and separating your database from your application all falls flat on its face. And that is something that one does not want to even begin to think about. So when you start building your IO servers, you have to start thinking carefully about where you're going with them and the direction in which you're going. Now, I've been using IO servers for all my application and database design and development since the year about 2002. So they've evolved. My IO servers have evolved significantly over time, but I have to admit that I haven't changed the style much in the last 5-6 years, because they seem to have settled down to be comfortable. And that's what you want. You need your IO services to be comfortable to your developers so they can use them easily. And that means setting up certain specific strategies to work within. And the first strategy that you have to establish is a naming convention. Proper, good naming convention for IO servers means that your developers don't have to think and don't have to go scratching around in large documents or through whatever other documentation you have to find an IO server that they need to use. They need to be able to define it as easily as if they were doing an FSpec. Because if you don't have that, then they are not going to use them. Because it's easier to use an FSpec. So you've got to make it at least as easy to use an IO server than to use an FSpec. Otherwise, what you're going to have to do is you're going to have to play the bully all the time, and you're going to have to keep checking people's code and whacking them on the head to force them down a road, whereas you don't need to. Make it easy, and you don't have to push them. And when they see the benefits they get out of it as a plus, they will then go down that road without any pushing. So, step one, a standardized naming convention for all IO server procedures. Now, because I have a standard file naming convention, which consists of 3 letters, which is the file group, followed by 3-letter stroke numbers, it doesn't matter, which indicate a sub-name of the group, and followed by an F, which stands for a physical file, because you spell physical F-I-Z-Z-I-K-A-L, as you all know. So an F stands for a physical file. You could use a T, which stands for table, if you really want to. But you all have pretty much established your databases, and you all have pretty much got your databases complete. And hopefully, you have implemented some sort of naming convention. Because your IO server has to be hooked to the file name. That's the important thing, because it's the file name that your developer knows. And I simply used the $sign. You can see I just added a $sign at the end of the file name to create the module name for the IO server. There it is there. It's the bound beginning. The B for beginning of the procedure. It's an exportable procedure. This is the beginning of the IO server procedure. And it has the file name with a $. On it. In this module, which has, by the way, got exactly the same name, it's the file plus a $, the module has the same name. And in this module, all IO services for this file are contained within the same module. That is also important. Most of the time, I only have one IO service. But there are a couple of occasions where I want to have more than one, so that if you call this one, it does that. If you call this one, it does that. So I can have more than one IO server within the same module. But then you've got to think again. You might have $1 and $2. You might have $, which is the primary one, and you might have $A or $B or something like that, which are supplementary IO services. But you need to decide on a standardized naming convention. You need to document it. You need to pin it up in front of every single developer so that you have a completely consistent naming convention for the creation of IO services. That's step 1. The second step to make life easy. Remember, an IO server is in fact a procedure which is called and has a parameter interface. I went through a number of iterations trying to decide on this parameter interface that I was going to provide for my IO services. I tried a number of things. It started at about 6 parameters and it's come down. It's now 3 parameters and it stayed as 3 parameters for the last 6 or 7 years. Those are 3 parameters which allow the user to drive the IO server to do just about anything that you want it to do and which it's coded to do. That's the important thing. And if you choose to do as I have done and drive it through a parameter interface containing 3 parameters, then, and this is important, then every single IO service, module, and procedure that you write must contain exactly the same 3 parameters used in exactly the same way. These are 2 big things with IO service programs that make their use and their capabilities easy for development. You can, if you're a fan of copybooks, you can define the parameter interface, the prototype, which is here. There's the prototype. You can define it in a copybook. You can use it in programs. You can put it into a program as a copybook, which means that it is one line of code which is exactly the same as one line of FSpec. I never do that. I like to see what I'm getting, and sometimes I have two parameters because you will notice that the third line is an optional parameter. Sometimes I have only two, sometimes I have three, and so I prefer just to cut and paste them in. But if you want the developer to only specify a single line, then you can put it in a copybook and let the copybook bring it in with its prototype, its three parameters, and 1, 2, 3 other fields. So in fact, I need all of those to drive an I/O service, and I will show you why and how. But that's the point. The name must be standardized, and the parameters and their definition must be standardized. Then it becomes very easy to use. Very simple, very easy. Now I'm just thinking, let me have a look here. I'm looking at this program because I want to show you two sides of the same coin. This here is a definition of the I/O server for cust MSTF. It has a prototype, and it has a pointer, a key structure, and of course the whole customer record, or the whole record for the file that you are writing the I/O server for. And this is the I/O server module. On this side, this here is the I/O server. Sorry, let me just get that back to the beginning. This is the after trigger of the customer master file, which is updating the balance master file and is therefore using the balance file's I/O server. And this is how you define the I/O server for using it to update the database. So you will see those two prototypes look almost identical except for a couple of things. One is the way this pointer is defined here as opposed to the way the pointer is defined here. The key is defined, the key structure is defined in exactly the same way. I hope you're all familiar with the use of star key in the external name definition. If there isn't, just flash or mute if you would like a further explanation of it. Okay, everybody's comfortable with that, and it's qualified. Why it's qualified is quite simply because that record definition and this one actually carry the same field names. So one of these two has to be qualified, otherwise this I/O module would not compile. Here, you've got exactly the same structure, but this one has a pointer address which points to the record there. That is initialized as being the address of the record. Right. So, when I want to use this, I will then call it using something like that. That's an external procedure call P, except the call P is dropped off because we don't need it. It's optional. And it's calling custbal $. And I'm going to open in this side so we can get an exact one-for-one match and we don't confuse anybody with anything, I have opened up the module for the customer balances IO server. So what I'm doing here is I'm saying call the customer balances IO server using the first parameter, which is the action parameter, a critical parameter, because this is the action parameter that you use to tell the IO server what to do. The I, as you see there, is an insert. So it means that I'm attempting to insert a record into the customer balances file. And the record is based at or based on this pointer, which is the second parameter here. Now, I have often been asked, why do I use a pointer? Why don't I just name the data structure? That one there. Because basically a named data structure, or if I go back up here, that one there. Because a named data structure is a parameter passed by reference, and we all know that passed by reference means a pointer is passed, which references the space. So effectively, it's exactly the same if I passed the record name as if I passed the data structure that is initialized with that record ID. And this is true enough. There's actually no difference if you are referring to a record ID. But if you wish to write an IO server that returns a buffer of 50 records, then you're going to have to point that IO server at another place altogether. You're going to have to point it at a space that can carry 50 records. And you can't do that using a structure name, but you can do that using a pointer. For example, you can fill a user space, and later on, much later on, we will talk about user spaces, but you can fill a user space with 50 records. A user space is addressed by a pointer. You can pass that pointer to your IO server, and your IO server code, depending on the action, because the action is what drives this, will be able to overlay that pointer on top of the structure and pick up 50-odd records. So, or populate with 50-odd records, or update your file with 50-odd records, or anything you choose to code. There's no limit to your imagination here. In this simple case, we are inserting a new record. We've populated the new record with values here. And we have called the IO server insert the record addressed by that pointer. So that call arrives here at the parameter interface of the IO server. The action carries an insert, and this pointer, this P, has a star, and it's carrying an address of the record structure as it is defined in this file on the right-hand side. So the record is defined within the application program and or stroke the trigger, depending on who's using the IO server. But the record structure and the space that contains the record, in this case, is defined in the application code. And the pointer to that space is passed into the IO server. Now that means that the IO server can use that pointer to overlay its own definition. There it is there. There's the definition. This one is based on cusbal FP. It's the same name, but cusbal FP is not initialized. It gets its value from here. Because the P, which is the field name for the parameter is placed into cus_bal fp, giving this record an address, which is actually in this file on the right-hand side, in this program on the right-hand side, but it's addressing it via that pointer. So this record we're looking at here on the left-hand side actually has now overlaid the record that is on the right-hand side. So I am looking at the same record space when I actually do that. I'm going to stop here and ask, are there any questions on what I've just said? Because this is very critical to understanding. And if you don't get it now, it may get a little bit wobbly later on. Because when I'm finished this, I'm going to turn it completely upside down on its head. So if you have questions, now's a good time to ask them. Okay. Action, by the way, is the A, which is 5 characters. Action code has been 5 characters for the last 7 years. I think it was about the last change I made to this style of IO server. And it was changed from 2 to 5 because somebody suggested to me that maybe I would want more action codes to be put in there. So I changed it to 5 and found that actually in 7 years I've never needed more than 2. Unfortunately, I can't change it back to 2 because then it's going to alter all the parameters, which means that all the IO servers are going to have to change, which means all the programs are going to have to change. And I'm not prepared to do that for 3 bytes per call. So although it sits at 5, if you look at the action structure, there's only A1 and A2. Move A to action, and that's how I split them into 2 pieces so that I can address them differently. Here, if the file is not open, open it. Now, that's where you create your open data path. This is a module. The file is defined as an fspec up the top, but the module opens it. If you look at the fspec up the top, you will see it's a user open. Commitment control is active on this because it is an update add file. And I've renamed the record name to REC so that I can talk about the record as a rec rather than the name of the file. It makes cut and pasting a bit easier. So, once we come into the IO server, we've had the call here to insert it. We come in here, we open the file if it's not open. This was, by the way, this percentage open was very much the nicest built-in function that they've added for a long time. I split my action code and I set my pointer, so I'm now addressing the record structure from the caller. Now, when there are 2 parameters, be very careful of this because remember the third parameter is a no-pass, i.e. it's an optional parameter. And if it's left out like it is here, it has a meaning, but I must never address it because if I address it, I'm going to get an error. So when palms are 2 and A1 is a D, which stands for delete, what my IO server then assumes is you are giving me a pointer to a record. Therefore, the key of the record that you want me to delete is in the record you're passing me, i.e. it's not in a separate key. Because with the delete action, I can pass the delete key as the third parameter or specify it within a record as the second parameter. So if the parameter is 2 and the request is a delete, I take the cus_bal fr record and I move it into bal fk because bal fk is a different data structure. Now, I am not sure whether you've come across eval corresponding before. But to me, it's the greatest opcode ever invented. Are you all very comfortable with what eval corresponding does? If not, just blink your... Okay. Let me just explain it very briefly. Eval corresponding will move fields from one data structure to another data structure based on the matching of the data name and its attributes, not its sequence. So it will move any field from cusbal FR to cusbal FK. Those are two data structures. And cusbal FK, you will see, is there, and it is a qualified data structure. As I explained, it has to be qualified because cusbal FR has the same fields in it. So by having the same fields, I can use the eval corresponding to move matching fields from the record into the key. They match by name and attribute. And defining the key this way and qualified means that one statement will move any matching records into the key structure in one single statement, no matter how many keys there are. It'll move all of them because they have matching names and attributes, because of the way they've been defined. This is one of the reasons why it's very important to consider rationalizing your data dictionary. Get away from this prefix-suffix naming, which we used to have to do. We don't need to do it anymore because we've got qualified data structures and we've got prefixes that are local program level prefixes instead of file level prefixes. So one needs to move towards common names for common data items. I think I've harped on that quite a bit. So here I populate the key. Otherwise, if there are three parameters, it means you've provided me with a key. There's the third parameter, it's a key. If there are three parameters, I then simply move K to the cusbal FK, which is the key data structure. So I'm assuming that you have provided me with the key. Notice that this key's definition is got a like the bal F key, so it has exactly the same structure as the actual key data structure that's defined up there as part of the naming convention. So, having done that, I have dealt with the three parameters. The action parameter is split. The balance has been, the pointer has been set to the originating record, which is in the application that is using the I/O server. And then I've dealt with the key if it has been provided. If the parameter is 2 and A1 is not a D, I don't do anything with the key because the key under those circumstances is treated in a different way. Then I come to the point here where you guys are going to have to start thinking about how you are going to use these I/O servers. I will make available, as I intend to do, all this example code, which you can use with the greatest of pleasure. It's the style and the setup and the construct has served me for quite some time. But of course, please understand that this is not the only way that you can write any of this stuff. Here, this is an RPG program. You can actually even write it in SQL. I wouldn't do that, but because I'm a RPG bigot, but you could write it in SQL. It wouldn't make any difference as long as you follow the parameter settings. Won't make any difference. So from this point onwards, you are coding the functionality that you are going to provide through this I/O server. And mine are pretty much standard. Insert, update, delete, read. I have a function for setting lower limits, and I have a function for setting limits greater than. Interesting part about these I/O servers, they don't set on LR, and they never close the file. I have a specific X action which closes the file. This means that the first time the file is opened, it stays open. And it stays open for the entire job that you're busy with. So it's always initialized, it's always open, and its file record pointer is always pointing at the last record that was addressed. So these are my basic actions. I put them in a when clause, and you can add or subtract to them depending entirely on what functions you require your I/O server to perform on behalf of the file. I can't stress that enough, because taking what I've got, all my I/O servers are working on normalized files, and this is basically what they do. I hardly ever need any additional functions than this. As a result, if you take what I've got, you're going to find that it's not going to work for you. In a lot, I would say a lot of circumstances, because your files will need different attention. Try and be as consistent as possible so that the action actually gels or relates to the action indicator. For example, an I should always be an insert of some sort. Right. This procedure has got an export, i.e. this means this procedure is exportable from the service program, which we are going to bind this service program into, this module into. These calls here are to other procedures lower down, because I have split all my I/O servers into their own procedures. And you will notice this procedure returns an indicator, i.e. it's not a procedure, it's a function. It doesn't have an export keyword. Therefore, it is only usable from within this module. And all it does is it writes the record and returns an indicator as on. Now, this might be being lazy. It's shorthand, and it's related to my use of the standardized error handlers. Remember this write, which is the put function, which is driven from the input, will return whatever the put function equates to, which is that indicator. If I write the record and anything goes wrong with that write, i.e. the trigger fails, there's a duplicate record on file, or any of the 101 things that go wrong with a record, with a write, when you're inserting a record, control will not pass to this return. Control will pass on error to the error handler 03, which will move up all the diagnostics and will then also resend the escape message. That is my major percolate. It moves up all the diagnostics and then resends the escape message to the caller. As a result, this program, that statement will fail with an I/O error. It will drop into the on error condition, and it will percolate the error up to the caller, which in this case, because this is an after trigger, will be the database management system, which will abort the process, and that will then percolate that back into your application program. Okay, so let's have a look again. Here it is an I. So I call the put routine, which is here. I execute the write, and if the write is 100% successful, I will return with an on condition, which means this put will evaluate to on, and I will return to the caller with an on condition. This is the caller, so the condition will be on. But I don't have to test it if I don't want to. The returning of the indicator indicates that the write was successful. But I don't have to test it. Because if the write wasn't successful, I would have ended up here anyway. Does that make sense to people? Are we comfortable with the use of this monitor on error condition? Because this is now where the rubber hits the road, actually, and we start getting the overlaps of functions and techniques to come together. So it's very important that if you have a question, please stop me, because I don't want to go too far if we have a problem. Okay. So there's a put. It does a simple write and return. I have to do a return because I have to return something, because it's a function. The update is exactly the same, update, except, and this is something that I've added to my I/O server, it's a new function which, well, put it this way, it's a function that is not supported by the standard RPG opcodes. That's what's so nice about I/O servers. You can make your own actions to do your own things. What this update does is it says, move what's in the record to the key. Now, I don't need the key because I'm updating this record, which is, of course, that record, because they occupy a common space because they're based on the same pointer. I'm repeating myself deliberately. I then do a chain because you know you can't update a record without first chaining to it. But I put the record into the save record, which is a data structure based like rec. I put it in there because if I didn't, it would put it into record, which of course would overwrite the record that's just been passed to me for update. You must work with this and be sure that you're comfortable with the way the code works, because otherwise you can't bend it to suit your own capabilities. And to use it as is without knowing how it works is a recipe for disaster. Okay, if I find it, i.e. if this chain finds the record, then I do an update and return an on. Again, if that update fails for any reason whatsoever, I end up here, percolate back up and percolate out. So update the record if it was found. But if it wasn't found, check the second byte of the action indicator. And if that contains an I, then execute a put or insert. So my action code UI is an action code that you don't get in RPG. It says, here's a record, update the existing record in the file, but if it isn't there, insert it. And I have found that particular little addition so tremendously useful, you have no idea. It's magic. As a result, this is what I can do with the I/O server. If the second byte is not an I, then I will return with an off to say that the update failed because I got an update, I chained to the record, it wasn't there, I wasn't asked to insert it, therefore I return off update failed. So that is a update, and it's got a slight kink in it to give me a new action code. Beautiful. I use it everywhere. Delete with a key. And return on. Obviously, again, if the delete failed, I would end up there. Now, the important thing about this is the key on the balance file is only one field long. Remember that. That is why this delete works, because it is a single field. Have I got? Yes, I have got one that's got more than one field in the key. We'll go through that now. Because files with single field keys are treated slightly differently from files with multiple field keys. Because you want to be able to handle partial deletes or partial key deletes, partial key reads, and so on and so forth. Let's go down here, set S, which is set lower limits. Now, I set lower limits using the key on the file. That sets lower limits to a particular customer number. And I return, we are returning a pointer here, but this time it's not an on-off, it's the percentage equal sign. So if I use set lower limits, I'm returning the equal indicator, which is valid for the set lower limits. Set greater than is exactly the same, except I'm returning a found indicator, which is valid for the set greater than. So although the parameter, the actual return value, is a 0 or a 1, depending on which procedure it's called, it's a different pointer that's returned. And this is why I say you've got to be consistent. Otherwise, your developers get completely confused. So you need to be absolutely consistent about these things. Right, here is the get. Get is split up into 1, 2, 3, 4, 5 different ways of behavior. We can get, which is an R in the first position and a blank in the second position. We take the key, assuming we have a full key, and we read a record and return the found or not found. So basically, we are reading a key. Here, RN, which is read next, goes to the get next routine, read previous, read next record, and read previous record. These two N, P, F, B, in the case of a single field, are actually exactly the same. They end up being exactly the same, except the get next uses a key, and the get previous uses a key. Whereas the read forward doesn't use a key, and the read backwards doesn't use a key. So subtly different, but with a single key field, no different. Really. Now, that's all my I/O server provides. Now, if you strip out all my comment, thought lines, and everything else, there's very little code in here. It's a basic, straightforward, simple I/O server. So all my I/O servers have approximately the same construct. I'm going to open this one. Which is actually the I/O server for the invoice details file. And this has 3 keys. I'm not going to go over what we've talked about. I'm going to scroll down. We have exactly the same actions right up to here. Oh, by the way, this other error 11 returns an escape message. If you call this I/O server with an action code other than one in this list, you will get back an I/O error, which says invalid use of the I/O server. That F11 is an escape message, and it will show up as an I/O error in your calling program. Okay, let's have a look at the subtle difference. There's no difference between the write, because you're writing from the record buffer that is shared via the pointer. Update, not a great deal of difference. I load the key from the record, and then I chain using the key into the save record, and then I do the same stuff. However, the delete changes. And this is something that I do wish, seriously do wish, that IBM would put right. And if there's anybody out there who has a hotline, a red phone into IBM, you might like to make this known. When you want to delete a record with a partial key, you can specify, use the percentage KDS, key data structure. You can specify the key structure, and you can specify a number of keys that you want to take into consideration when you are doing the delete. So this little loop here, do until, not found, delete with one key only, i.e. only the first key out of the key structure. And then undo, and you loop around those 3. Deleting all the records that have exactly the same customer number. Now, the reason it's written this way, you put a D1, you delete on 1 key. You put a D2, you get a delete on 2. You put a D3, you delete on 3 keys, which is the full key. And if you put anything else, it tells you it's an invalid use. Here's the message again. The reason that has to be done this way, and if any of you can come up with a slicker, neater way of doing this, I'm all ears. In fact, I'm going to change this particular thing to SQL, because SQL does it better. However, if I change this to SQL, this I/O server will open 2 open data paths. One for the SPEC and one for the SQL. So I haven't done it because I don't want 2 data paths when I can get away with 1. So there's a choice to make there. This parameter cannot be a variable in this built-in function. If it could be, it would be wonderful, because then you could collapse this completely, but this parameter is not allowed to be a variable, and therefore you have to specify each one, which means if your file has 15 keys, in order to provide full functionality, you have to do this 15 times. Not too concerned about that, because a select when is a very nice tool, and it only goes down as far as you have to go, and then it hops down to the end. So that is a problem, and that is how I handle the deletes here, to remove partial keys. By the way, D3 and D blank are effectively exactly the same function. But I put them both in case the user gives me a D3 instead of a D blank. Set lower limits. When you've got more than one key, you have to actually identify how many keys you are asking for, because I can set lower limits S1, S2, or S3 in this case. So the first action code is an S to say set lower limits. The second one is the number of keys. And I have to take those keys and I store them. Now remember what I said, I never close this program, I never close these files. So if I call this IO server with an S2, it will set the key count to 2. And then will return, and it will either have the equal condition on or off. The next time I call it, I will call it with a read next, because I set the lower limits. Now I want to read next, i.e. I want to read the first record with that key. So I've stored the keys. Using the set lower limits, the next call will be the read next, which means it will read the next record. Similarly with the greater than, do exactly the same thing. Set greater than, it's exactly the same, it's just going the other way. When we get to the get, if it's exactly the same, if it's a blank, there's a chain on the full key, because it's assumed that it's all keys. If it's an N, go to get next. If it's a P, go to get previous. And you can do things like you can set lower limits using the set S, but you can get previous by reading backwards from there. That you can do. It doesn't stop you doing any of the functionality that you can do on a normal opcode. Or read forward, which is without a key, and read backwards, which is without a key. Get next says, when the keys, now this is the number that was stored on the previous call to the set lower limits. So if keys are 1, read equal with a key data structure of using only the 1. So you will read the next record in the key group based on key 1 only. If keys were 2, you read next based on 2 keys. Otherwise, you read the full key. You read forward on the full key. Same with previous. It does exactly the same. So when you've got multiple keys, you have to consider, if you want to provide the functionality, and I'll come back again to this, if you want to provide the functionality for processing partial keys, which is pretty much a standard when you're reading blocks of data, then you need to provide these services within the IO server. And unfortunately, this KDS, when this KDS allows a variable in that position, I will be so happy, because then this will collapse into a single statement, because keys will simply go where the 1 is. And there won't be any when or select or anything like that. So that's super. Okay. Now, you've got control through the put routine to do anything you like with a put, insert, and let's just have a look at this customer master, because this customer master, I think, yes, I've got one. In my little simulated world here, customer number, and in a new customer number always gets the next number from the file. So I have added a few lines of code to make this happen, i.e., the application does not go and fetch the customer number. The I/O server goes and fetches the customer number. The first thing you do is you set high value on the customer master file, and then you read previous into the save record. And of course, this particular condition will only ever happen once when you have an empty file. If you've encountered end of file condition, put a 1 in the customer number, else bump the customer number from the save record by 1 and populate customer number. Now, the important reason why this is being done in the I/O server and not in the trigger, because it could also be done in the trigger. But the real valid and important reason why this is done in the I/O server is that, remember, the program that is using this I/O server is sharing the record space via the pointer. There's the pointer there, and you saw higher up, there's the pointer there. So you're sharing the record space. And therefore, when I add this customer number, when I populate the customer number in the record space, the record space is actually in the clients, in the calling programs buffers. So I'm populating the customer number in the calling program, which means that when the I/O server returns control to the calling program will have the new customer number available to it should it need to do anything else with that. Doing this inside the trigger you can, but it means that the calling program does not have access to the number that was allocated for that insert. And you can't change to the file because you don't know what the customer number was that was assigned. So it means that it's difficult to know which customer you've just added if you put it in the trigger. If you use this little bit of code in the I/O server, then the calling application will know exactly what the customer number was that was assigned. And it can then use it to, I don't know, pay somebody or write them a letter to say welcome to the company, or whatever you plan to do with it, but at least it's available. Not having it is a nuisance. So in the case of this sequential numbering, I always do it in the I/O server, and it happens automatically. What it also does is it means that the application program code that does this can be taken out, and the definition for the file that does this can be taken out. I'm just going to ask if anybody uses things like data areas for last number used and so on and so forth, because that is a fairly common technique. I prefer this one of picking the last record on the file and bumping the number by 1, because then the immediately following that is the write, which means that you have read the record, you've locked it because it's been read for update, you then write the record. That means you can't get duplicates. Nobody else can take that number away from you. It's assigned at the point in time in which it is written to the file. So you can get no conflicts using this technique. If you use data areas or other files to hold last number used or that sort of thing, then it can cause conflicts. Or if the user cancels the operation, then you lose a number goes missing. Whereas if in this particular case, if somebody cancels the operation and your application program does a rollback, then in fact you recover that number, and that number there will then be reused for the next insert. So it's a tidier way of doing it. Okay. I/O servers can be built to match any requirement that you may have. If you can build them around a standard parameter list that essentially, really the standard action should be IUDRSGX. That's it. You can have other action codes that can allow the developer to access as much exotic code as you please. You can write it all into the I/O server. You test it in its procedures, in its I/O server. I always have a little test program for I/O servers. Make sure they're working, but there again, that was a long time ago. These days, all my I/O servers are cut and pasted. And I barely have to test them at all because they're so standard. It's only the little extra pieces of code that you plop in that you might need to actually do one or two quick tests to make sure they're working. Once it's working, it gets bound into the service program and away you go. Right, let's look at what you do once you have compiled your module. Remember, this is a module. I'm going to see if I can find my let's just have a look at this view. I want to have a look at the outline view. There's the outline. Sorry, it's going to occupy. I'm going to move that into that tab so that I can toggle between these and still retain some decent space on the front. Okay. This one has got an export on it. These are the prototypes. All the other procedures do not have exports. So only this procedure is actually being exported to the service program. That means these procedures are used internally for this, and you will find that every one of my I/O servers has exactly the same names for its internal procedures, because there's no point in changing them because they're not being exported, so they will not clash, because they're only usable within the module. Okay. No, I was going to say something there. You will notice also there are no main modules. Taken the main line out completely. I want to point out one thing about this. These are the keys field. Is in the section of the program above the first procedure, and this section of the program is global data definitions, i.e. data definitions in this space are available to all procedures, which is why when I do, let me find the other one, sorry. When I do the sets on the keys value in set S procedure, it's actually available here in the get next procedure. It's available here because it is in the global data definitions above the first procedure. If it was defined within the set-s procedure, it wouldn't be available to any other procedure. So it's an important consideration. If you find yourself losing data, that's the first place you look. Have you got it defined above or below? Remember also that any global data definitions are initialized only on the first entry to the program or to the module. Any local data definitions, if there are any, are initialized on every entry to that procedure. Because they're local to the procedure, they get initialized when you enter the procedure. That's something that will probably come up again. Okay, so having written your IO server module, you'll see I've got that special type code RPG LEM, which indicates that it is a module, and you've compiled it. Then we can go and have a look at how you bind all these together. Now, in my AO database, I have 90, I think the last count was about 96 different files, different physical files. So technically speaking, my service program should have about 90 different procedures. However, if I add all my logical files to that as well, it becomes a little bit of a large service program. So what I preferred to do in my case with AO is I split it. In this case, I haven't split it. So what we have is we have a CL program called CUS IOS. Now notice what I've done here. It's part of my standard naming conventions. There we are. I've called it CUS IOS. It takes the 3 letters of the files. It was supposed to only deal with the customer master files, but I'm actually going to defend myself. I put this one in as well. So actually, I've broken my own naming conventions right here, right now, right in front of you. And I admit it. Not always things go according to plan, but one has to try and push things in the right direction. I have got 3 modules. Remember, an IO server is a module. So I've got the 3 modules. I could pack them into 1 or 2 modules, but then it's difficult to find them. It's difficult to know where they are. I then have an export for the source file, and there I've got my source file name and library and the source member name. So that is the binder source. We had a long conversation about binder source. Signature value v1.0 and 3 symbols, export symbol table, only the 3 IO service procedures. So that's stored in the source member definition there, which is the binder source, which is controlling the service program. So in this particular case, your export symbol list will be the same as your module list. The only difference being the module list you can put in order, and I'm going to reiterate again, the export symbol list, you never change its order. You always add to the bottom, no matter how OCD you are. You have to do that, otherwise you're going to have to recompile everything. And with IO servers, that could be, once you've got them embedded and they're working for you, that could be a big job. It's text, binder service program. These generally only use the error handler services, but sometimes they use other service programs, which you obviously have to put in that list. You compile this CL, and then you call it to create the service program. And if we look here, objects AMWDB, I think I did compile it. Here it is here. The standard is the same. It's CUS iOS ADAT, which is the service program. And if I open it, I got a module and a procedure. Oh, sorry, that's the program. I'm looking for... The only thing that I have an issue with around RDI versus the operating system is that they have a different alphabetical sequence. There it is there. And there you see, there's the service program itself compiled. It has 3 modules in it, and each module has those procedures in it. That's the bound service program that carries these 3 IO servers. And obviously, you can write IO servers for every single one of your files. Now, as we discussed earlier, you can write an IO server for a file, and you can change programs into using it one at a time over time. Again, it follows the AO and Tembo roadmap, which is focused completely and myopically on being able to progress towards a modern database in small bites with the minimum amount of risk. We accept, as I have said to you before, and I will say to you again, this is not something you do at the click of a button over a weekend. If you expect that, then you're going to be disappointed, I'm afraid. But it does mean that you want to be able to move forward on a continuous basis with as little risk as possible. And once you start with these IO servers, you will begin to see the potential for them. As long as you realize that looking at this code that I will provide you, is not the only way to write the story. And your needs in terms of your database and your protection of the data in your database and all that sort of thing is very, very important to what you put in your IO servers. And it's the same with the triggers. Triggers, IO servers, triggers. Those two together are the total protection, together with the referential constraints, are the total protection for your database. And they are the most significant and most important components of a modern database. And the benefits to your application code are, if you do your triggers and IO servers right, you can throw away 80% of your current lines of RPG code. Now, that is where the name of the game is. That's what we're aiming at, is to move code into triggers, to move code into IO servers that are common to the file, not to the program, and leave behind only that code which is program, application, or function specific. Let the database do the heavy lifting. Now, I do use embedded SQL on occasion when I find it beneficial to me. I know in the audience I have some serious SQL fundies. I'm an old dog, I'm an RPG bigot, and all my IO servers are actually written in RPG. But there's nothing to stop you writing them in SQL. As long as you follow the basic rules. of parameters and passing this record structure or this space. You could put an entire record set from one select of a SQL statement. Now, I'm talking here, and please, I could be completely off base, but you take a record set and you can dump it into a structure, and it could contain 1 or 2 or 3,000 records. You can do that using an I/O server because you're managing the whole common area with a single pointer. So it's easy to do. The important thing here, I would say, something that if you're going this way, you need to play. We don't often get chance to play, but you need, in this case, to play. You need to select a file. You need to write an I/O server for that file, and then you need to create a little test program and see how it works. Unfortunately, as you are aware from last week, I'm leaving on Saturday for Wisconsin, and as a result, I have been unable to get the code to you, or at least hooked up to the meeting, the meetings in WebEx. Hopefully, I will have some time before the conference. My priorities. Fortunately, with the comms that we have at the moment and the way we work, I can do it just as well from Wisconsin as I can do it from South Africa. So I will get these to you just as soon as I possibly can, and take them and play with them. It's really, honestly and truly, the only way to become comfortable. If you just take them, compile them, and just start hammering them out and not customizing them to your needs, you are really going to find that you're going to paint yourself into a corner. And just to give you an example of that, I'm going to take this program, which is the customer master after trigger, which updates the balances file. Okay. And the pointer to this record structure, the pointer is initialized as the address of this record structure. So that pointer is pointing to this data structure which defines the whole record. And that pointer is passed through here as a parameter to the I/O server. Which one? It's that one there. It's passed through to the I/O server as a pointer here. And the record here, which is based on that pointer, doesn't occupy any space in the I/O server, because it is based on a pointer that has no value. It can't have a space. It's only when we create a value in that pointer does this record overlay the pointer position, which of course will be this area there. So that is defining the space, the record space in the application program, and passing a pointer to that space into the I/O server. Now, let me throw a real curveball at you and see how you like this one. It'll happen, and then I'll be able to say good night, and you can go and take a headache pill. Let us assume that I didn't want this pointer as a parameter. It seems redundant. So what I could do is I could take this, and I'm going to do this code change in front of you, but I'm going to then undo it. I'm not going to compile it. I could take this initialize routine from here, and I could put it over here. Now, what am I doing? I am now initializing this pointer in the IO server module with a value that points to here. As a result, I can't use that based on, because I would then have a conflict. So what has happened here is this pointer is now pointing to a space, a record space, that is defined inside the service program. Now all I have to do is I have to put a keyword up here, exporting that pointer from the service program, and then I can drop this as a parameter. Why? Because on this side, I won't have that. Instead, I would have an import, i.e. I'm importing the pointer from the IO server, and therefore the record is based on the pointer. Now what we've done here, and that pointer there will come out because I don't need it. I'm passing it instead through an export import. So what has happened is we've changed this around so that the actual space occupied by the record is actually defined in the IO server. It is addressed by a pointer that is exported to anybody who wants to use it. And you use it by importing it and basing your record structure on that pointer. And in fact, what we've got is we've got the thing exactly the opposite way around. And we have removed one parameter from the list. Now, I wish I had cooked this scheme up before I had actually finalized my IO servers, but my IO servers were finalized 15 years ago or 10 years ago. And this particular switching the pointer into the IO server, I only got taught a couple of years ago. Otherwise, it would have got rid of a parameter for me and made it that much easier to live. Because now or to work with. Now I have keys which are optional and the action parameter. Oh. But I could also put the action parameter and the keys as exports from the IO service. Couldn't I? I could move them into the IO server and just base them on this side on pointers, which means I could eliminate all the parameters and only have the indicator coming back. So it's probably not done you much good for me to tell you one way and then flip it around the other way. But I've done it deliberately because where a pointer is defined and where it is used is optional in or outside the service programs. We discussed this, and I said you need sometimes to have your service programs initialized with a star immediate or not. Now, there are a few cautions about doing this. And I'm still I haven't done the tests completely, but there are still some circumstances, particularly when we get to activation groups in the integrated language environment, where sometimes I have noticed this type of defining a pointer inside the service program instead of inside your program tends to get a little bit unstuck when we are in and out of activation groups. So I am going to provide the code the way it always was, so that nobody can come and beat me up because it doesn't work. But it can work for you, for other service programs. I've got lots of service programs where the pointers are defined inside the service program and not inside the application code. And I import them because then it makes that space common across many different programs using the same service program. And that is extremely powerful. Now, service programs are the best thing to focus on very seriously, because it is here in the service programs and in their procedures and in their modules where you gather common code, i.e. the I/O stuff for a particular file is used all over your application. It's gathered into a procedure in a service program. It's only ever written once. It's used by everybody. And if you want to change it, you just change the service program, and that change immediately takes effect throughout the application. We've got a few minutes left, so I'm just going to, I haven't got an example here in the dummy system, but I think I do have an example in real-time system, if I can just find it. As I said to you, I write an I/O server for every physical file. I also write an I/O server for every logical file that I have. And I'm looking for one in particular. Where I have a join. Whenever you join two files together, that is either via a DDS join or a SQL view, those open data paths are not updatable, because you have no, that's not the one I wanted. This is a logical file that I created. It has quite a long key, and it only provides a set lower limits, a read, and a close function. It doesn't provide anything else. That one actually is not a good one, but this one. Here is a joined file. You can see there are 3 physical files that are joined, and there's a key, and it also has an omit to omit certain records out of that file. It has an I/O server. This I/O server is restricted to the read operation, the set limits, and the get. There's a new one here for save the current position, reset the current position, the last saved position, and so on and so forth. But this one you can't do an update. I can't find the one. There's one. I should have looked this one up before I started this session. It's another join. I don't think this one. No. Now, I'll have to find it and show it to you next week. But the point here is that if you have a logical file, You can have an I/O server for that too. And if the logical file is not updatable, you can bypass that within the I/O server by having your reads on your logical, but your inserts, your updates, and your deletes are actually within the I/O server addressed to the physicals that make up the logical. So that even a logical file without an updatable data path can have and can be updated by your applications using exactly the same techniques. From an application developer's point of view, they're given a file. They don't even know it's a joined file. And they update it using exactly the same procedures and methods as they would update any file that they're working with. And that, if you go back, I can't remember what session it was, to the CODS 12 rules, that is one of the rules that you are satisfying by using I/O servers. Because the client application doesn't know what's behind it. It's using a standard interface to update the file, no matter how it's constructed behind the scenes. And if one of the files that is joined produces a trigger error because the data is not correct, it will return to the client program as an error in exactly the same way as everything else does. So it will behave in an absolutely consistent manner. And that's really when you're modernizing and when you're trying to consolidate code into one place, you want this high degree of consistent utilization so that everybody can become comfortable and familiar with how these things work. It makes the coding so much easier. And let me just point out something here that I am sure every single development shop in the world suffers from. It's called pigeonholing. This is my parting shot for tonight. It's called pigeonholing. As a developer, you've been with a company for many years, and you have developed a large number of functions, programs, applications, whatever you like to call them. And of course, when something goes wrong, they call on you to fix it because you know the most about it. And as time goes by, you become the go-to person for anything that goes wrong with that function, application, or whatever it is. You get pigeonholed. It means that if you are on leave, sick, or not available for any reason, and something goes wrong with the stuff that, in inverted commas, belongs to you, one of two things happen. Either, if it's very urgent, somebody else who doesn't know your style, doesn't know anything about the application, and is possibly somebody a little more junior, is given the task of trying to find the problem and fix it. Outcome there, not good. And generally speaking, it's a band-aid which breaks, and hopefully you get back from leave in time to fix it properly. But you get pigeonholed together with certain applications. Now, the more that you move down the road towards common procedures, triggers, standardized style of coding, standardized names for files, fields, I/O servers, everything, as you move down more and more into a standard environment, the problem with pigeonholing begins to disappear. I ran a development shop with 8 developers. We were turnkey and enhancement solution consultants. And I had 8 developers with me. When they started, they all had their own style and their own way of doing things. And I used to send somebody out to do a contract and write a couple of programs for customer A. And if customer A had any problems, I had to find that person and send them. And it took me around about 4 years to get them to actually write code in my style. I had to choose a style. The best one for me was my style. The beginning was a strain for them. They suffered. But after 4 years, they were writing code that you could not tell who had actually written it, which meant that anything that a customer needed, I could send any available programmer to go and look at the problem or fix the problem or enhance that particular application, because they were all totally comfortable with the code, style, function, capability, and methodology. And this is probably the most unappreciated part of modernizing your application code, is that you can begin to use your resources more broadly for better solutions, and you don't have pigeonholing taking place. It works. And now, in the newer functionality where you have triggers, where you can button up a whole bunch of code, you've got I/O servers. And now we will talk a little bit next time on the enhancement of I/O servers to become enterprise servers. That all of those things are grouping code together in one place, testing it once, making sure it works, don't change it, and your production code becomes simpler, becomes cleaner, becomes neater, and then becomes more available to more of your team. And that can have huge benefits for development shops where you run sort of 6 upwards developers, when you're not pigeonholing them anymore, and you can have them do anything you like with anything, and it all looks the same in the end. Massive benefits, massive reduction in testing time, testing effort, and time to production, which means that you don't, everybody says, oh, gee, if you go that route, you're going to get rid of half my department. No, that's not the intention, and that's not the purpose. The purpose is to actually get them to actually do stuff that's more productive, to produce faster, to produce better quality, to actually tackle the backlog that most shops face, instead of wasting cycles trying to keep stuff going or to fix or band-aid unnecessarily. That's the whole purpose behind this thing. And it starts at the database with triggers and I/O servers. Okay. Are there any questions to what I've rushed you through today? Because you've had a pounding. I will get the code to you as soon as I possibly can. That's a promise. And if you want to send me emails, okay, sorry, Matthew, ASCII versus EBCDIC. Oh, it's Thursday I'm going to talk to you, not next week. Okay, Matthew, Matt, you asked me about ASCII versus EBCDIC. Can you be a little bit more specific? Oh, is that what the sort issue is on RDI versus IBM? I thought it had to be something weird like that. I wonder why we can't standardize. Okay. All right, ladies and gentlemen, unless there are any other questions, thank you for your time. I will see you next Thursday. And Matt says ASCII puts numbers first, which is irritating when you have to compare one to the other. But what can we do? Thank you very much, and enjoy the rest of your day. Night.